As we get into the unit about energy changes and during phase changes, I've set up a demonstration to show you what actually happens in real life when you heat ice for an extended period of time. So I have set up a computer. This is a computer. The computer is connected by a temperature probe to this pan of ice that's sitting right here. I'm going to turn on the stove and just monitor the temperature change as time goes by. I want you to notice that the original temperature here is right at 0 degrees C, which is the freezing point of water, which makes sense because the thermometer is sitting in this pan full of frozen water. You can see that I've begun to heat the ice at 0 degrees C. I turn on the burner. You heard the click, and you can hear the flame perhaps. And as I heat the ice, you can see the temperature starting to raise a little bit. But what looked like is going to just shoot up actually didn't shoot up, kind of flatlined again. So you'd think that as you're heating this, that the temperature would just rise constantly. And you can tell it is going up. Oh, that's how it's going back down, but I'm just stirring the ice as it melts. Continuing to stir. It's kind of hot over here where I'm stirring. I'm stirring with the thermometer. So the temperature doesn't just go straight up while the ice is melting. Continue to stir, although it is trying to increase. And the reason it's trying to do that is because I don't have completely even temperature changes while the ice begins to melt. Some parts of the pan of ice and water are warm and some parts of the pan are cold. But I think you'll see that when the ice is all melted, which isn't going to be long now, that the temperature will start to go up a lot faster. Normally I would have you do something like this in class, or we would do it while class is, while we're doing something else and have this running in the background, but these are kind of special times. My temperature is still not just skyrocketing. At this point, you can hear me stirring, and the ice is almost all gone. So I'm getting closer and closer to having just plain old water in the pan that I showed you earlier. Still stirring. And now I'm going to let the experiment continue without stirring. And I'm just going to heat it. Oops, there we go. And you can see here that the temperature now is starting to rise at a faster pace. I'm going to go ahead and let this video run so I don't have to splice so much. But if you need to fast forward, if you'd like to fast forward at this time, you can go on to the end. You'll see what happens as we continue to heat. Right there, you might be able to tell that I let the thermometer slip and pulled it out of the water briefly, but now we're going up again. Same thing happened. I got a little current of water in there that wasn't quite as hot, and stir a little bit more, kind of quit stirring. Now we have the water, it's a little bit warmer than room temperature. Getting close to what would be your normal body temperature, which would be about 37 degrees on the Celsius scale. Again, at this point in the video, the temperature is just changing gradually. Go ahead and fast forward until you're near the end. When the if you fast forward and look at it and the temperature is about 95, 90, 95, that's when you would slow it down and watch it again. You can hear the water is almost starting to boil. It's kind of sizzling over there on the edges of the pan. I moved the thermometer a little bit. You can see the drop in the temperature while I moved it. Now it's steady again. Water is just beginning to boil. It's not a rolling boil yet, but it's boiling in places. A rolling boil would be where you've got bubbles all over the pan and things are just steam's rolling out of it. It hasn't quite reached that point. But now it has reached the point where it's boiling vigorously. And we'll continue to watch the temperature for another couple minutes. Of course, the normal boiling point for water is 100 degrees, but that's at sea level, and we're a little bit above sea level. So we might see it boiling at a little bit lower temperature. I want you to note that I'm continuing to heat this water, but notice that the temperature is not going up anymore. It's staying constant right in that range of 94.5, 0.6. So I'll let it go to the end of this interval on 180 seconds. These are recording in 180-second intervals. I'm just adding every time. So we'll let it run for just a few more seconds until the button at the top turns green. Again, notice that the temperature is not changing significantly. There I hit 100, but not for long, and that has to do with where the water current's inside the pan. The average here is just a little bit less than 100, which makes sense because we're a little bit above sea level. Water boils at 100 degrees at sea level. And I'm stirring a little bit. You can see the temperature fluctuate just a little bit. But essentially, if you look up here, the temperature has flatlined when it began to boil. And that's the point of this demonstration. During a phase change means melting or boiling, there will not be a temperature change. It shows up better in this demonstration at the boiling point than it does at the freezing point, because here, or the melting point, here you can see that the temperature basically stabilized here and is continuing to remain stable as I heat it. I let the thermometer touch the bottom of the pan. I got a little glitch right there. But for the last, 200 seconds, the temperature has essentially remained constant. Back at the beginning, it wasn't quite as obvious. We got a little bit of an increase because as I was stirring the pan of ice, I had a little bit of uneven water currents inside the pan, so it's harder to show that the temperature doesn't change at all during melting. However, you can certainly see that the rate of increase here was much less than it was over here after the ice is all melted. This is the point where the ice was all gone right in here. And up until then, I was trying to keep the temperature constant by stirring, which is hard to do. All right, and I'm getting the thermometer close in the bottom of the pan, so I'm moving the thermometer, that's why you see this little fluctuation over here. All right, so during a phase change, no temperature change. Temperature changes when you're heating something within a phase. Right here, this was liquid. This was where we started with solid, and then of course we're boiling up here. If I boiled all the water away and collected the steam, then I could raise the temperature above 100, but I can't get the temperature to go above 100 until the water is all boiled away. All right, so temperature change exists when you're not doing a phase change, but when you're melting or boiling, temperature will remain constant.